So about 30 years ago, everybody said it was all about ball bearings. It's the wave of the future. Well, I'd advocate to you that now it's all about parallel systems, distributed systems, cloud computing. It's the wave of the future. We found over the last couple years that advances in technology, the way people are using technology, computing services, has changed, such that notions of parallel computing, distributed computing, both of which drive this cloud computing initiative that we're seeing, really has brought that to the forefront and made it even possible. Look at various things like economies of scale, feasibility, resilience, and security. All of these are reasons why this has just exploded over the last couple years. From people wanting to get out of hosting their own data center. You know what? I'd rather take the 30 servers that I've got, let Amazon, let Google, let somebody else manage those servers for me. I don't have to have a data center anymore. I don't have the costs associated with the space, the costs associated with purchasing, maintaining the hardware, and the costs associated with the environmental, cooling, heating, power, etc., of that facility anymore. I can get all of that through the cloud. The feasibility from the standpoint of processing power has gotten exponentially, or reverse exponentially, asymptotically cheaper over the last few years, as has storage space. So as those costs decrease over time, this becomes a much more powerful concept because you can leverage the economies of scale, and it wasn't even possible 5-10 years ago. Now, incredible performance, incredible capabilities. The idea that if I have one data center, in order to achieve some type of resilience, I now have to have a data center, another one, a duplicate one, at least 50 miles away, or geographically separated. That way, if something happens here, it doesn't wipe me out. I've got another backup that I can go to. So to achieve resilience, instead of having to maintain 2 data centers, I can put servers in the cloud on 2 different sides of the country, around the world, and achieve that same level of resilience. And from a security perspective, people are migrating to parallel distributed systems because it allows them to segregate or segment their operations. So rather than having one server which does everything, I can now have 3 servers, 5 servers, 10 servers that handle the workload of that or different aspects of that server, so that I don't have all my eggs in that one basket. There is a difference between parallel processing and distributed processing. They're complementary, and sometimes people use the same terminology, overrun the terms, so they get confused quite a bit. But they are 2 distinct processes. Parallel systems achieve or use multiple nodes or processors for performing a task on a single data set. So you've got one data, multiple processors all working on it. There are 2 types of this. There are data parallelism, where everything is, each node is working on the same size chunk of data, although it might be it's different chunks. Or they're working on task parallelism, meaning each task is being done, rather than being done in sequence, they're being done at the same time. Now you have to have good ways of chunking up data and defining tasks to achieve this and actually see the benefits of it. But that's what parallel systems are focused on. Distributed systems, conversely, are focused on a set of data and a set of data and a processor that are working on that. Then over here, there's another processor and another set of data that's working on that as well. And then over here, there's a duplicate of that. And so you've got multiple nodes performing distinct tasks, and it's usually independent of each other. To kind of make sense of that, it helps to have a diagram. So here we have this parallel concept where you've got one chunk of data and 3 processors working on it. If you look at cloud computing, what you see is one big chunk of data with multiple virtual machines or servers chewing on that particular data. A distributed system, conversely then, is again, you've got a distinct processor and data working on in concert with other nodes that are doing something with a processor and another chunk of data. And they're all communicating back and forth to each other using some type of control protocol or message to kind of balance who's operating on what to achieve the overall task that it's been set out to do. You see that within peer-to-peer networks, where you've got no single point of control, but each of the nodes is working together to accomplish some broader task. So from a system security perspective, parallel computing has really been focused on the processor and the memory configurations, but now really it's turned to looking at systems of computers, systems of systems, how they collaborate, how they interact with each other. So from peer-to-peer networks, which have gotten a bad rap, to virtualization, client-server architectures, and cloud computing. All of these are new concepts with which security is trying to get worked into. Kind of the way I equate this is we had a great idea, we started running with it, and then went, oh, well, we probably ought to do something with security in each of these ideas. From a peer-to-peer perspective, again, peer-to-peer networks are distributed where the actual resource, the computer, the node, the laptop, whatever you want to call it, are spread out geographically, logically. They're all different, and there's no central controlling device. There's no single node in charge going, okay, processor 1, you do this, processor 2, you do that. The way that the members of the peer-to-peer network communicate is just by passing messages back and forth to each other. Each operates independently except for those messages that get passed back and forth to coordinate the overall output of it. You see examples of this within content delivery networks, like the major media outlets. Let's just arbitrarily pick Disney, Google, Facebook. They all have content delivery networks. And so these are individual servers that are set up out there. There are hundreds of them. And based on wherever you are in the world, when you ask for, say Facebook, I'm asking for a Facebook page, you're going to one of those content delivery network servers, probably the closest one to you, and you're getting the content from there. And as I said, peer-to-peer networks have gotten a bad rap from BitTorrent and various other file sharing applications that are out there. On the upside, these types of networks do provide a lot of redundancy, not in terms of just the data, but also the processing power, so that you can achieve very resilient operations. File sharing networks, on the downside here, file sharing networks are frequently targeted for malware distribution to enable massive malware infections. And unfortunately, peer-to-peer networks are responsible for most of the piracy, distribution, illegal copying, that sort of thing that's going on the internet. I will say that peer-to-peer networks have gotten a bad rap as, oh, that's for file sharing or for whatever. But this really is an interesting concept of parallel computing, distributed networks as well, that allows you to do a lot of capabilities with it. But we haven't seen a whole lot of it other than for various illicit means.